All right, 5.2 is what's called the substitution rule involving integrals. All right, and what it is, it's the integration by substitution is a way to find the antiderivative, or to work backwards from the derivative that resulted from the chain rule. This is undoing the chain rule. And this is the last rule that we're going to go over in this class. Now, technically, there are additional rules that we won't get to, like integration by parts and those. There is a form up online, but again, we won't run out of time to do that one. So this is the last rule that you're going to have to know for antiderivatives. So like I said, there's fewer rules for antiderivatives. There's the basic rules that we went over in 5.2, and then the undoing the chain rule, substitution rule, which undoes my chain rule. Alright, so we're going to kind of work through an example that it should be fairly obvious that this function was a result of the chain rule. Alright, so the function we're going to start off with, or the integration we're going to start off with, is integrating the function 2x times e raised to the x squared. Remember, this is the differential equation. This is the derivative. We want to know, we want to know the antiderivative. We want to undo the chain rule. Well, this was the derivative. Alright, what function was found, what function has the derivative 2x e to the x squared? Well, the basic function is f of x e to the x squared, right? If I look at this function's derivative is that now there would be some constant that we could tack on in the end. And we will do that when we set it up in the general case. But if you take the derivative of this, you do get that expression, right? And it involves the chain rule, right? The derivative is the original function e to the x squared times the derivative of the inside, which was 2x, and then it was just rewritten. And we can rewrite it, right? It's just changing the order of multiplication, which we are allowed to do, right? 3 times 2 is the same as 2 times 3. Right, and that was the function whose derivative is that expression 2x e to the x squared. Which again, this one should be one that hopefully you can see that that's the answer. Now we are going to walk through the same example using the substitution rule that we'll be using for the other examples. Alright, the steps to solving by substitution. Alright, there is an alternative way to do this, and if you know the alternative way to do this, you can feel free to use the alternative way than what we do. But this is sort of the general way that I am going to set up. So this is, again, the substitution by integration. Substituting, alright, to get rid of the chain rule. Alright, the first thing is we want to get rid of all of the inside function parts. Alright, so the first step is then I need to make sure I know what the inside function is. And the inside function is whatever function's the innermost. Right? It's inside of another function. And so in our example, which I'm going to write here, which is at the start of this page, this x squared is inside the e function, right? It's the innermost function. 2x is not inside any function. The e is not inside any function. X squared, however, is inside the exponential. And so that's what I want to let my u equal. U equals the inside function. So that's my inside function. Alright, that's my first expression I want to make sure I recognize and I'm going to substitute out. Alright, so inside function I let be u is equal to the x squared, which is inside the e function. Alright, remember, when we used the chain rule, we took the derivative of the inside, so I want to recognize what the derivative of the inside is. I also want to get rid of that expression. And so we take the derivative of the inside, and we're going to do it in a way where we're going to set it up with the ratio du dx is going to equal that derivative. And so I'm going to write my u was equal to the x squared, right? That's my u, and this is my g of x function, right? U equals g of x. And so when we take the derivative, I'm going to write it using the du dx. Take the derivative of my function part, which is x squared, right? I'm looking here, which is 2x, right? That's the derivative of the inside. So that's the inside derivative. All right, which is what we did when we did the chain rule, right? The chain rule is take the derivative of the outside times the derivative of the inside. All right, that's the other piece I'm going to want to get rid of. And actually, I'm going to rewrite it because I want to get rid of all of the inside function parts, meaning I want to get rid of all of the x terms. All right, so my next step is we want to solve for an expression of du. All right, I want to get my function in terms of u. I want to substitute out all of the x terms, including the change in x, the dx. Alright, so looking at my example above, and I'm going to write down what I have. My u function was x squared. My du over dx was equal to 2x. And so what we do is when we look back at my example, 2x e to the x squared, and sometimes with dx, since that dx is important because I use it, it's sometimes helpful to reorder. So what I mean by reorder here is to see what I want to get rid of. Alright, so this is just a multiplication. And so I can reorder that e to the x squared times 2x with respect to x. This I'm already replacing with u. I want to get rid of all of this part. That's the derivative of the inside, including the du, the change in x. That's the differential with respect to x. And so what I need to do is, well, I need to move this dx over here, right? I need to have it equal to that expression. Well, I'm going to multiply both sides by that dx. Right, and so I get du equals 2x dx. Now I've got everything that I need. There's the two pieces I'm going to use to substitute out all of my x terms, including the dx. This is going to be equal to du, change in u. And so that's what I do. I now substitute them out. So this is the big substitution step. Get rid of the inside function and the derivative of the inside function, which are the x parts, and what I'm going to be left with is the outside function in terms of u. Alright, so the outside function in terms of u. Alright, so when I do this substitution, so this is what we're doing, we're substituting out, I'm replacing the x squared with u, right, that's what x squared is equal to u, and I'm replacing the 2x dx with du, right, that's what 2x dx equals u. And when I do that, alright, so I'm substituting out. So this is the substitution step. I get e to the u du, right? I got rid of the x squared. That's where the e to the u comes from. It's now e to the u instead of e to the x squared. I got rid of the 2x dx because it equaled my du, and so I replaced 2x dx with du. And now I've converted the entire integration to only involving the u variable, right? Which again, what I'm left with is this is the outside function only in terms of u. Right? I've gotten rid of all of the inside. I've undone all of the inside function parts. Now I'm ready to take my antiderivative. Now I'm ready to integrate. Alright, now you integrate the resulting expression with respect to u. So I'm going to rewrite it here so I can integrate it. Again, if you can't, it means you missubstituted or messed up your derivative in some way. If you can't integrate. So at this point now I can use my integral rules, right? The antiderivative of e to the u is just e to the u plus some unknown constant. Alright, so the general antiderivative with respect to u is e to the u plus some unknown constant. Alright, then there's one last substitution step back. Alright, right now it's in terms of u. Alright, well I don't want my final expression to be in terms of u. I want it to be in terms of my x value, right, which was my original function. And so you got to put back the x term. Well, remember what u equaled. U equaled x squared. And so I've got to go and plug that back in here. And so now my general antiderivative instead of u is x, where I replace the u with the x squared function plus c, and there is my rule. Right, the antiderivative of 2x e to the x squared with respect to x is equal to e to the x squared plus c, and it checks, right? If I take the derivative of my antiderivative, right, if I take the derivative of e to the x squared plus c, well, the c will zero out. I'll get e to the x squared times 2x, which is my original function, right? This original function, and there's just in a different order, but it's the exact same function. All right, so now we're just going to practice that. All right, so the next examples are just going to be practicing the substitution rule. All right, and so that is going to be my next set of notes.